Assalamualaikum brothers and sisters. Okay, so today I'm going to show a video on Pspice. So if you have downloaded the light small folder, okay, so you go to this one, and when you open it, you will see this setup application. Okay, setup application file, and when you run it, please run as administrator. Okay, and then you can install the software. Okay, so once you have installed the software, if possible in drive C, you have to go and find the folder cadence. Okay, so inside cadence ni, you will see the Orcad 16.6 light folder, and you want to open this one, Orcad capture CIS light. Okay, so you open this one. Okay, and you will see this window. Okay, so let's start doing one project. So we start by go to the file menu and choose project. So let's call this testing 1. So make sure it is analog or mix AD, and I have created a folder called project in the C drive before I proceed with this software. Okay, so I'm going to save all my projects in this folder from now on, basically. Okay, so once I click OK, you want to create a blank project. So you create a blank project and you just choose OK. Right, so you will see this page with all this grid. Okay, so let's say that you want to construct this circuit. Okay, so all these parts we're going to edit using this. Okay, so I hope that you can see that this is called add parts. Let me move this bit. Okay, so when you click this, you will see a list of libraries. So in order to add this list of libraries, you're going to click this. Okay, so there is this add library icon. So when you click that, it will direct you to this list of library. So you're going to select all. Okay, and then you're going to click open. So after that, you will be able to have all the list of libraries. Okay, now let's start with the DC voltage. So for DC voltage, the library is source. Okay, so the library is source, so you're going to find a DC voltage. So DC voltage is VDC. So you just double click and you're gonna have it here. You can see here in the grid. So you just click there, and in order to choose another part, you just click escape, so it will be gone, right? So the next one is resistor. So for resistor, it is under library analog. Okay, so you go to analog, you will see the resistor R. Okay, so you double click again, so you will see R. So how many resistor you have? You have 3. So 1, and then in order to make it vertical, you just press R. Press R in your keyboard, and so it will rotate. Okay, let's say that you already placed the part and you want to rotate, you can just right hand click and you can see rotate here as well, so not a problem. Right, so now you want to connect all these parts using wire. Okay, so wires are here, place wire. Okay, just to let you know that if you want to do this schematic using this software, it is easier if you use a mouse. Okay, using the how to say, the pad on your laptop ni, it's a bit troublesome. So might as well if you have a mouse, it's easier, right? Okay, so now you want to place wire. So let me zoom this a bit. Okay, so you just make sure that you click on the square there. Okay, and then you just drag and click. I hope you can hear the click sound. Okay, so don't drag the wire like this. Okay, so that's wrong. Okay, so you just leave it at the point where the square is, right? So then continue again. Alright, and then like this. Okay, then connect with the power supply, and finally this. Okay, most of the students error is because they just continue, so the wire overlaps the parts, so that's one of the way they can make error. Okay, so that's done. You have completed the circuit. So now you want to, let's see what are the values. So it's 1 kilo ohm, 1 kilo ohm, 1 kilo ohm. That's what we have here. And to change the value of the power supply, you just double click that and you just put 10 volt. Okay, make sure there is no space, just 10 volt. Okay, right. But you still cannot simulate this because you must include ground. So ground is included by clicking this. See, place ground. You can see here the libraries for ground is here. So under the library cap sim, you just choose 0 because you want it to be 0 volt, right? So you just gonna put it here. Okay, and don't forget to connect this to the rest of the circuit. So now this node is grounded. Okay, and you're done. Right. Okay, so before I forget, of course you can change the values of the resistor. Similar method, you just double click on the values and just put whatever value there. The default unit is kilo ohm. So if you want to do 100 ohm, for example, you can just put 100, or you can use 0.1 K, right? So doesn't matter as long as you will get 100 ohm, but the default unit is kilo ohm, right? Okay, so normally this kind of circuit, you just want to know what is the value of the voltages and what is the value of the current. So what you need to do is just firstly you need to create the simulation profile. So in order to do that, you must go to Pspice. So new simulation profile. So normally the name of my simulation profile is I take the value of my project, which is testing 1 just now, and I just put sim at the end so that I know that this simulation profile is for this project. Okay, so just create. So when you click create, this window will pop up. Okay, and this is the simulation settings window. Okay, because at the moment I just want to see the values of current and voltages. Okay, that doesn't change with time, so I just click OK for now. Alright, and so then you can see that the top icons here, okay, appear. Alright, just now before you did the simulation profile, you don't see this. Alright, you want to see the voltage and the current, so you click there. You can see that there are changes in the box. So you just, if you unclick, you don't see it anymore. Okay, so you need to click the V for voltage, I for the current. If you bring your mouse at the top, you will see what is the description, right? So then you just click run. Okay, so if there are no errors, you will be able to see all these values. Okay, so if there is error, for example, let's say if I remove my ground, so now this node is open, right? So let's say if I run it, okay, so you will see this blinking icon here. So you can see where is the error. So node 0099. Okay, so where is this? You can just check where is that node. So if you move your mouse over the nodes, okay, so you can see which node that it is referring to. Okay, so it says that that node is floating. Let me double check. Node 00126 is floating, 106 and 099. So 126 is this node, right? Yes, so that is the node that is floating. Okay, so let me just close this error. Okay, so let me just bring back my ground. Okay, so I'm gonna run it again, and I can see the current. So this means that this node is 10 volt. the current flowing through your R1 is 6.667 milliampere. This node is 3.33 volt. Okay, and the current flowing through this branch is this value, and so on. So this is how you can read the data. Okay, and of course you can prove this by doing the theoretical calculation. Okay, so another thing that this simulation can give you is the power calculation. So if you click W here, okay, which is watt basically. So if you click that, this is the power calculation. So for example, your DC supply is dissipating power, so that's why it's negative sign. So if you multiply the V and the I, you will get this value. As for the resistors, okay, you can see that the powers are positive because they consume power, and the formula uses power equivalent to I squared R. So for example, the resistor here is 1 kilo ohm and the current here is 6.667 milliampere. So if I use this website calculator here to calculate power, so if I key in here 0.00667 ampere and 1000 ohm, and I calculate, I will get the value of the power here, 0.04444 watt, which is equivalent to 44.44 milliwatt. Which is what I get here, right? So same thing, okay? You will get the same output if you multiply I squared R, and when you add these three values, it must be equivalent to 66.67 milliwatt, which is the definition of power consumption must be equivalent to the power dissipated. Okay, so that is the end of part 1. And for part 2, I'm going to show you a simulation when you have a time varying input signal, such as a sine wave. Okay, bye. Assalamualaikum.